We live in a world of sensor miniaturization. This transition's happening for gas sensors right now, just like what had happened for gyroscopes 30 years ago. But what we're interested in is how we can change the world. We've designed a new product called Faraday Ox, which is the world's first oxygen sensor from the semiconductor industry.
Okay, Ryan, thank you so much for being here. I'm really happy that we have this opportunity to make this interview. We already talked a bit with Rainer at the trade show for Logistica last week, and I would like to elaborate more about the company and about the motivation that pushed you guys to elaborate sensors for O2 monitoring. So that would be great if you can tell us more about the company history and how did it all start.
Perfect. Yes, I'm happy to be here as well. And the company history really starts with myself and my co-founder, and the business needed in the world today when it comes to gas detection. We live in a world of sensor miniaturization. It is really the driving force for a lot of the devices we see around us. They used to be big and expensive, hard to integrate. The semiconductor industry has made them small, more cost-effective, and easy to integrate. This transition's happening for gas sensors right now. Just like what had happened for gyroscopes 30 years ago, it's happening for gas sensors today. And we saw a business need for oxygen detection, which is a gas sensor that has been difficult to miniaturize in this industry because of the technology normally used to detect it. And so we saw that need, and we also had a technology that we believed could address that need. This is something that I've been working on for over 10 years in my research career, combined with another 10 years of my co-founder. This is innovation in semiconductor, sensors, electrochemistry, and even fundamental synthetic chemistry to solve this problem. And by combining expertise at the founder level and consulting with the industry, especially when it comes to oxygen detection, we've designed a new product called Faraday Ox, which is the world's first oxygen sensor from the semiconductor industry.
Fantastic. Well, that was a short, brief, but very precise explanation. Tell me, when you elaborate something that is so unique and first on the market, you must have stumbled upon many obstacles, or not, maybe not many, but could you enumerate certain barriers that you stumbled upon while elaborating the solutions and commercializing it?
There's obviously a technical barrier because this is a very new technology. We're technical guys, my co-founder and I, we have a great team. So this is something that we can address piece by piece. But in order to effectuate change in the world, you need to get it out there. And understanding where to begin is always a challenge because you want to have the greatest impact in the world as much as you can. You want it to be sustainable. You want it to be quick. All of this is something that takes a lot of work, business development, and speaking to people going out into the world and learning where this actually can be used. We had known before where oxygen detection is used today, used in safety applications, medical, there are plenty more. But what we're interested in is how we can change the world. How can we introduce this technology in a way that people maybe are not accustomed to today, but can nonetheless provide value that is not being realized. And so we spoke to people in food, in logistics, and the question is, where is this data really important? And it's important wherever an action can be implemented. And so we discovered very quickly that packaging is one area where this is needed, especially in supply chain.
How would you say the new solution differ from the ones that were already on the market?
Well, the big difference is that what's on the market today is not a semiconductor solution. It's a solution developed maybe 60, 70 years ago. Typically used in industrial devices, processes. These are big, replaceable, I would say analog components. That's not what the world needs today. The world is much more integrated than it was 60 years ago. There's IoT, there's communication protocols, but then there's a new cost pressure that comes with that. If your plan is to deploy, say, 10,000, 50,000, 100,000 units, the technology today just is not meant for that. It's too expensive. Not only from a hardware standpoint, but from a calibration standpoint, you actually need to put effort into using this component. What you need today is basically what exists for, say, the gyroscope industry, where these are just little MEMS devices. You don't think twice about integration, fits on the board and it works. That's what the industry needs for gas detection, and that transition is happening today.
we will have an offer for our clients that would be different depending on the application and depending where the clients would like to use the sensors. Would you be so kind and elaborate why it's so important to have different options for different applications?
Absolutely. One of the biggest problems in gas detection in general is always calibration. Sensors must be calibrated, and normally in the industry today, that's done at the device or even customer level. Imagine every customer needing to calibrate the device themselves. We have changed that for these types of sensors. We do the calibration internally. And this is important because what we provide in the end requires no additional work on the calibration front. But this means we need to calibrate internally, making sure that the solution that the sensor is addressing matches the calibration that we do. So for the different solutions that we target, we calibrate accordingly and make sure that the sensor performs exactly as the client needs for their solution. And in this way, we have different options to provide that quality.
And different ranges.
And different oxygen ranges as well.
Oxygen, exactly. So the client, in the end, receives a ready-to-use device. So nothing must be done to the device. The client receives a ready-to-use project.
Exactly, as they expect with, say, temperature, humidity, and gyroscopes and all of this.
Fantastic. But it takes a lot of technical competence and knowledge to elaborate such a solution. And a personal question for you: how did you end up in this sector? Why sensor and metrics, and why you were drawn to this in the first place?
Yeah, very good question. Well, I think when you're a research scientist, you always want your technology to have an impact. My co-founder really is the pioneer in the idea of miniaturized oxygen detection and bringing it from everywhere from industrial processes to individual food packaging, and collecting data in a essentially en masse in a way that has never been done before. So I'm inspired by my co-founder and his vision as well. And together we realized, hey, this is a huge opportunity. We really need to put some effort into this and become a leader in oxygen detection, anywhere where it's needed.
And right now it's within your reach.
It's absolutely within our reach.
Let's say within hours.
Within hours, even better. We have great supporters and partners to do this. And we, of course, look forward to the future and deploying this all around the world.
I'm already happy because I'm thinking that the next interview will be actually with both of you. So we can speak further about the cooperation. So that would be the continuation of the series about the oxygen monitoring. Thank you, Ryan, for being here.
Thank you for having me.
Thank you.